in the previous time we met, we left things near the end of the 70s, maybe getting into early 80s a little bit. That's where we stopped the discussion. So I think it would be very interesting to continue from where we left off. We had talked about, the last thing we talked about was the 1979 ASCE conference on geophysical methods.
Oh, in Atlanta.
Yes.
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 Yes. And I think I was a bit in error when I indicated that in that conference, almost all of the papers were on seismic methods. That's not right.
Okay.
We had a broad spectrum of geophysical methods described at that conference.
Okay.
And it emphasized geophysics to some extent with the geotechnical community, but it didn't gain a lot of traction.
I see. I see. Yeah, although there's still a committee on geophysics within the ASCE Institute.
Yes, but that didn't happen until in the mid-'80s.
Oh, I see.
Before that committee got established.
I see. Okay. So in around 1980, if I'm not mistaken, you were doing some work on soil improvement.
Yes.
Can you talk about that?
The goal, of course, was to improve shear modulus with the intent of reducing ground motion caused by machinery. And the hope was that you could go underneath existing foundations and improve the ground, thereby reducing the vibrations that they generated. So our first approach was to do typical grouting, and the biggest argument against not using grouting was cost, and that the chemicals involved were costly as one of the main issues. So we were quickly able to establish that you don't have to fill the entire void with a cementing material, that is a grout, to achieve the maximum benefit of grouting. That, as a matter of fact, all you needed to do was to fill the capillary space at the contacts of grain to grain. And this represents something on the order of, not precisely, but on the order of about 10% of the void volume. With that percentage, you could in fact then cement the system of grains together and improve shear modulus. So we did considerable experimentation in that direction, and attempting to use various grouting materials. But the grad student T.S. Chang was observing the process that in a observation tank that we built, grouting a saturated material, and it was he observed that pumping the grout into the ground, in fact, pushed the water out along a very defined surface. That the difference in density and viscosity and so forth between the grout and the water was sufficient to create a front. Well, he was smart enough to think at the time that, what if this was gasoline instead of water? And so we worked with the environmental group in our department, AveryDemond, was contacted, and she suggested a surrogate for gasoline, so we didn't have to use gasoline in the laboratory. And we would saturate the sand with the surrogate and then pump grout. And again, certain grouts, not all grouts, formed this same front with gasoline, or the surrogate for gasoline, and it pushed the material out and cleaned the void space. Well, this looked like a promising approach to cleaning up gasoline spills and possibly other chemical contaminations. And so, of course, the light went on, patent, my grad student and I attended a conference, Great Lakes Geotechnical and Geoenvironmental Conference in Chicago, where, in fact, we met and had discussion with a representative of the Natural Gas Producers Association. That probably isn't the right name for it, but in any case, a group of that type. And he said, "Oh yes, that works. We patented that about 5 years ago." So our great hopes for an approach to contamination remediation were dashed, and our student finished the thesis and one additional after that, as a matter of fact. But we were too late to generate a patent. Unfortunately, it seems like that patent squelched all additional progress, as patents often do, for some period of time before anything becomes of them. And I don't know of any real-time application of that process in the remediation of contaminated ground. The initial attempt to improve ground by grouting was continued much later. After I retired from the University of Michigan, I taught for a while at Notre Dame, and I had a PhD student there also, and she proceeded to attempt to grout clays and to mix clays with cementing materials, and so that was improvement of ground that was much finer than sands and could not be easily improved by grouting techniques. In any case, that was sort of where all of our attempts in ground improvement came to an end.
Interesting. But it's interesting to see how they started with the isolation, and considering the grouting as one of the techniques, it went into environmental aspects associated with that. So it's very, very interesting now. And all that so that's 1980 or so? Well, the original.
Around 1980, yes. Yeah.
Okay. Now, at the same time, you were working on piles also?
Yes. This whole era from mid-70s through mid-80s was a era of intense nuclear power plant construction. With that in mind, Bechtel Corporation established an office in Ann Arbor specifically to work on the Midland nuclear power plant, but also worked on several others from this office. one of our earlier master's students worked for Bechtel and, and wanted to go on for a PhD. His name was DennisGlee, and so it turned out that one of the things that Bechtel was looking at the time was the dynamic response of piles. And Denny took up that topic as his thesis topic. So with his connection to Bechtel and many of their jobs, not just their nuclear power, but other power stations that they were connected with and designing and maintaining and remodeling and so forth, Denny had access to very large pile projects. And so he was able to actually shake existing deep piles and instrument the piles. And
Oh, wow.
so with his foot in the door and a possibility of looking at many real life experiences, we spent about, I guess 10 or 12 years with at least one student all of the time working on dynamic response of piles. I believe that Denny's work confirmed the predictions of Professor Novak from Western Ontario on the response of piles when they're loaded dynamically. The program by Milos Novak was called Pile A. He did a Pile A too, but that was a minor augmentation of the first program. And the important point was that it was clear from his analyses and from our experiments that it is the soil material, the reaction material near the surface of the ground that controls the dynamic response. And by near, we probably mean not more than 5 pile diameters deep, which is pretty shallow. There's certainly in some very weak soils the influence of the soil near the surface may go deeper, but it's a pretty shallow response. Glee was able to mainly test the condition of a free-ended pile. It's very difficult to get into a fixed situation, but the free-ended pile in several kinds of soils were clearly measured by Glee and consistent results, and results which could be modeled more or less correctly by the Novak Pile A program. Later on in the 80s, I don't know if we want to maybe cover it then, but another student by the name of Hassini looked at the dynamic response of pile groups. And his goal was to use the Poulos approach from pile statics to pile dynamics in predicting the dynamic response of pile groups. He did it with model piles in our indoor soil bin, and was able to model the fixed pile cap arrangement as well as the free, and obtained some excellent results along that work, with that work, both in static response, steady state response, and plucking response. So he covered the ballpark, and his thesis was too long to fit in one book. But so we had an era in which we were constantly looking at the response of piles, and it seemed like our concentration sort of moved from one thing to another with each era and group of students, but all with a focus on dynamic response.
Dynamic response.
Yeah.
Yeah, no, and at the same time you were doing, there was all this time, the SASW work that you were doing also, so it's
Yes, that began in the early 80s. Stokey and his students, in particular Sohail Nazarian, published their first work on SASW, and I described earlier in these discussions the build-up to the SASW method that required dual channel FFT analysis, and the analyses had to be coherent, and that was one of the complications. But Stokey recognized the instrument developed by Hewlett-Packard, a two-channel FFT, and proceeded with Nazarian to develop the SASW technique. Well, there were a lot of components associated with SASW, that is spectral analysis of surface waves, in particular ways of what do I want to say, the screen of the analyzer wrapped information with regard to phase, because the screen has only a certain depth. It could describe only going so far. You couldn't go further with a graph, so it would wrap, and then again and wrap. So the phase information with respect to time and then eventually wave velocity, the first step was to unwrap the phase.
phase unwrapping, yes.
And DennisHiltunen was our student who first looked at that. I'm wrong. We were talking about the era of NenadGucunski.
Yes.
Nenad was the first to look at that unwrapping. And then the second issues were in the matching of a hypothetical layered system to the dispersion curve that was measured from the field data. And Nenad's thesis was devoted to that process, and he used the general structural analysis of a multi-story building and modeled the layered soil in that way, and was able to establish the dispersion curve of the modeled soil structure, hypothetical layering, and then compare that with the measured. Nenad spent about 4 years with that process, and Dennis picked up on that and carried on then until about 1990. Maybe just a side issue, NenadGucunski also started early enough that he carried on with DennisGlee's work to some extent, trying to make use of the Pile A2 program by Novak to model the experimental results of GLEE, and had some success, but it was pretty clear from Gucunski's work and that earlier work of GLEE that one could choose an upper layer with zero stiffness and a model of the gap that is left when you cycle a pile to and fro. And you eventually wind up with a space that is no longer in contact with the pile, and then you soften your program further with depth, and that was facilitated with the Pile A2 program that Gucunski started with. He morphed then into SASW when that became clearly an important tool in geotechnical engineering.
Interesting. Very interesting to hear about the connections. And because in 1983, if I'm not mistaken, you gave your state-of-the-art lecture on measurement applications of shear wave velocity for soil structure interaction. Is that part of the same theme, or?
Yeah, absolutely, yeah. And of course that brings in the piles, the pile work, and the SASW concept.
So that state-of-the-art was in Roorkee, India.
Yes.
That's the Prakash conference, or that's something different? Which conference is that where this took place?
I'm going to have to look that one up.
Okay.
HarrySeed and Andy Valetsos were the principal speakers at that conference.
I see.
And I was one of the second level state-of-the-art presenters.
Because he had the soil dynamics series of conferences and the case history series of conferences, so it could be one of the two.
You know, and at this moment I can't remember which that belonged to.
Yeah, we'll find it. Yeah, we'll find it. Yeah. So that was the theme in general, though, this type of work?
Oh, that's right. Principally the pile work and the SASW.
Okay. Yeah, so it would be interesting we have that paper probably somewhere. Huh?
Oh, yes.
Yes. So we should make sure we add that in.
Surely.
For sure. Okay. And then this was in 1983, but at the same time, there was you had this connection with Zhejiang University in China.
Yes, well, it started in '81 when they sent the first student from mainland China to University of Michigan, and Wu Shiming was his name, and he came from Zhejiang University. The connection, of course, was through Bill Richard. He had made connection with Professor Zheng at Zhejiang, and Wu came to Michigan. And he completed his PhD 83-84 era. Yeah.
Okay, and I think eventually we'll talk about more detail for each of the students. Okay. Well, along with research around that period, I know you got engaged with the American Society of Civil Engineers, and there was also the 1985 conference, international conference with ISSMGE. So if you can tell us about this whole, and USUCGER is there also. So
yes,
maybe you could tell us about this.
There were a lot of things going on there, and because of Professor Richard's long involvement with ASCE, he was a good friend and worked with JohnFocht, and in 1980 or 81 in that region, JohnFocht was was chairman of the Soil Mechanics and Foundation Engineering Division of ASCE. And JohnFocht was searching for someone to become the newsletter editor for the Soil Mechanics Foundation Division. And Bill Richard suggested me, and John asked me to do it, and I agreed. And so from 1980 or 81, I don't recall exactly the starting date, I was the newsletter editor, continued till 1985. That, of course, involved just gathering information from whatever sources I could find and putting together a quarterly newsletter.
That was, I mean, now that in 2018 we're talking about newsletter, we're thinking electronically.
Well, true, and we're looking at a much a bigger operation,
Yeah.
something that is totally independent of functioning faculty members. So it has grown considerably, but during that era, we were looking to expand the scope of the newsletter and its coverage, and we were considering North America. So the Canadians and the Mexicans, both doing excellent work in geotechnical, well then, soil mechanics. In any case, we had discussions with representatives of both of those countries and their geotechnical groups, and an outfit called Biotech Publishers in Vancouver, British Columbia. John, maybe I'll think of his name as we go. In any case, he was a member of the Canadian Geotechnical Society, and he was operating a newsletter of sorts for Canada. And so we had negotiations for 2 or 3 years that led to the Geotechnical News. And Geotechnical News was published by Biotech Publishers and had 3 sections. It had 2 sections only in English, and that was the Mexican and the United States segments.
Oh,
And
the Canadian one?
the Canadian was French and English.
Oh, really?
Oh, yes.
Okay.
Oh yes, they have a strong enough Eastern Canada influence that that must be in French as well as English.
The Mexican was in English, not in Spanish.
Not in Spanish,
Okay.
That's right. It was like pulling teeth to get material from Mexico.
I see.
We just didn't quite have the same kind of a relationship with the Mexican society. But in any case, as a matter of fact, that publication continues through today. It is now just the newsletter of the Canadian Geotechnical Society, but it has some very excellent articles and covers the news. Of course, we have Geostrata now, and even ASCE is sending along with the Civil Engineering Magazine a newsletter type sheet. So in any case, I started my involvement with ASCE internal organizations as a newsletter editor. I was fortunate enough to get an award for that operation because each division had a newsletter in those days, and so in Geotech we came out as the leader for one of the years in any case. But with the necessary connections that I had to have for the newsletter operation, I was in contact with a number of the leaders in Geotech, BobWhitman and HarrySeed and of course JohnFocht and some of the others in practice. So as the organization for the 11th International Conference on Soil Mechanics and Foundation Engineering got underway, HarrySeed approached me for some work associated with that operation, and he selected and appointed Vince Drenovich and myself to be editors of the post-conference volume.
Oh.
So in that role, throughout the conference, Vince and I tried to cover all the sessions with the help of some professional photographers to get photographs of every speaker. And I believe we accomplished that with only one or two exceptions. And so their photographs are all in the post-conference volume. My connection with HarrySeed during those years was also along another line, and we may want to talk about that separately. That was the Geotechnical Centrifuge operation. But in any case, we enjoyed that conference. I think maybe I'll move a little bit ahead in chronology here, because associated with the 11th International Conference, which, by the way, earned a substantial amount of money for the U.S. National Committee, which organized that conference. In 1987, 89, we had the next international conference in Rio de Janeiro. HarrySeed pledged at the 11th conference that any profit would be distributed among the organizations that helped in organizing the 11th International Conference, and some help for the U.S. National Committee. Well, I was the U.S. National Committee representative at the 12th International Conference in Rio, and was privileged to present a check to the International Society. At that time, the president was BengtBroms. A check for $25,000 for the International Society of Soil Mechanics and Foundation Engineering, and that was all a result of the outstanding work that HarrySeed did in organizing that 11th International Conference.
Oh wow, I see. And well, this was, understand, a very major conference. I have heard a lot about it, and I have seen the volumes also.
Well, it was certainly the best of any that I've attended, and I've attended from Montreal, I guess all of them except for Egypt, Alexandria, and Germany, Hanover.
Oh wow. Wow. I see.
Well, of course, the venue was outstanding, and one of the best hotels in San Francisco, the Fairmont, on top of the hill. So it was just all superlative, and Harry made sure that it was all that way.
I see. But the other thing that came out of this conference, I understand, is also USUCGER or something. Can you tell us more about this?
Yes. In the early 80s, most of us in academic research were clamoring to obtain National Science Foundation grants, and that the budget and the organization at NSF was continually being for geotechnical engineering was continually being reduced, and that by early to mid 1980s was a very small pot to divide up, and did not seem to be getting much recognition from the organizers at NSF. So HarrySeed pulled together a group of geotechnical engineers during the 11th International Conference, and to discuss the possibilities. And one of the possibilities was an organization of geotechnical engineers, specifically those associated with academics, to lobby NSF and Congress to provide additional funding for research in geotechnical engineering. So out of that informal meeting came the concept of a group of academics who would then lead this effort. But at the same time, we would, by we, the informal group, would try to pressure NSF into providing a position for an academic to work at NSF. And so at the time, Charles Babendreyer was the NSF contact with the geotechnical group, and through his good offices we actually obtained that position. Then the question was, well, who would fill that role? And during the San Francisco informal meeting, RoyOlson from Texas offered to take that position. So by the time of the first formal meeting of a group which became known as the United States Universities Council on Geotechnical Engineering Research, USUCGER, that position was established, and Roy was on his way.
Oh, wow.
Maybe already there by the time we had our Houston meeting. The first president, in my recollection, was WayneClough. I became the second president, and I believe MikeONeil was the third, but we need to confirm those names. But the point was, by the time of our Houston meeting, we had already succeeded with 50% of our goals, and that was to get a representative in the tent, so to speak, at NSF. Roy did an excellent job. And so our second goal of additional lobbying and so forth, while still was valid, was a little less urgent. And so during my term in office, we considered bringing in all geotechnical engineers with an intent of maybe increasing funding for non-academic research and U.S. government labs and so forth. That didn't gain much traction with the practitioner community. So it did not continue on for more than a couple of years, while USUCGER continues to be an organization, and I think it is still devoted to promotion of funding for academic research.
And education, though, it has a big education.
It has now a additional role. You're right.
That was not much of a thought at that time, or was it?
No, it was not.
Oh, wow. Interesting. It's good to know. So when WayneClough was probably the first president, you said we're gonna check. You were vice president at that time?
Yes,
or? Okay.
yes.
Interesting. Very interesting. Okay. What about you mentioned the AAC, you mentioned the Houston conference. What is that Houston conference you said by Houston?
Well, it was strictly a USUCGER
meeting. Okay,
yeah.
okay. So it was always separate from ASCE, separate activity from the ASCE. I know you were active also during that period of time with the Geotechnical division of the ASCE. And maybe you can talk about that. But those two were completely separate from the beginning.
Yes, they were. I don't know whether that was the intent of Professor Seed, but that was the reality.
I see. So what about your involvement with the Geotechnical division of ASCE? I think after that.
Well, after the term as editor of the newsletter, I was asked to join the executive committee. In those days, the Soil Mechanics Foundation Division was administered by an executive committee. And the executive committee was composed of 5 people and a past president. Now, one of the individuals was the secretary, and the secretary was expected to hold that position for 2 years before becoming a regular member of the board of directors, or the board of the executive committee. I was asked to join, skipping the secretary 2 years. So I joined the executive committee such that my presidency was 87, 88. And you just moved up in the executive committee annually.
I see.
Depending upon whether the secretary was eligible to come in at that time or not. If he was, then he or she was, then someone else was asked to take the secretary position. So it may be that I was selected in a year when they didn't need to replace the secretary. So in any case, you move through 3 positions on the board and then become president, and then you stay on a year after as a past president.
Okay, kind of what I think happens with the Geo Institute right now.
Well, I'm not surprised.
Yeah, so it's the same.
That has a similar mode. I don't know. At that time, the selection of the new member was pretty much up to the existing executive committee.
I see.
When I was on the executive committee, at least we sought nominations from the division as a whole, and then made selections. And there was no election, so to speak, involved in those days.
I see.
Now, another part of the executive committee was the U.S. National Committee of the International Society for Soil Mechanics and Foundation Engineering. And so the U.S. Secretary of the U.S. National Committee was also set on the Geotech Division Executive Committee.
I see.
And that for probably 20 years was HarveyWahls from North Carolina State. So we had a connection to the international society, and therefore the string of events that I described earlier, where Harry pledged profits to the international society, then that sort of came through our U.S. National Society, and I was just finishing my presidency or the after year, and made the presentation to BengtBroms in Rio de Janeiro. So that I was pretty heavily involved with ASCE activities throughout the 1980s, from my newsletter days through the executive committee.
I see. Wow. Okay. Very interesting. Very interesting. So I know there's you have been active throughout in lots of different roles in your in service, and you've done lots of different things. One that I think we skipped, and maybe we could discuss about it now, is the National Geotechnical Experimentation sites. And if you want to talk about that, I know I've heard of these sites, but really I haven't, I know there are a few of them, but if you can tell us more about that also.
Yes. I was not involved in the earliest stages when NSF was encouraged to establish a national geotechnical centrifuge facility. During the 70s, there was a lot of discussion, both in terms of technical papers, but at geotechnical meetings, about the advantages that such a facility might provide.
Yes.
The idea, of course, is pretty simple. With many kinds of structures, you can make a model and extrapolate from the model quite clearly what the prototype behavior might be. Building structures in particular can be modeled that way, and you can model them in one gravity. You don't have to, because of their relative size and weight and so forth, you don't have to worry about modeling gravity. But in geotechnical structures, we're talking principally dams and levees, and of course cuts, and the influence of gravity on stress and strength is dominant. So if you build a model in the lab of a dam and it's 1 meter high, that will not behave at all like a 100-meter deep or high dam. So the whole idea was we need to have a facility that all geotechnical engineers could have access to. There were a few centrifuges around the country. I know there was one at Purdue and University of Florida and UC Davis, small centrifuges that were producing some research, but were quite small. The most widely used application was Boeing Aircraft Company, but not what you think, not in building airplanes. Boeing was involved in research as well, and they used a centrifuge that had a capacity of 1,000 Gs but only a very small mass. And they used it to perform cratering experiments for the defense operation. And they just had small, say about a foot diameter soil models, and they set off a blasting cap. And they were pretty good with that modeling. And that got the widespread notoriety. Secondly, in the 30s, somebody in rock mechanics had thought about the same kind of issue. That is, in fact, deep into rocks, their self-weight controls stresses and strength and failures. So someone by the name of Bucky developed a small centrifuge and showed that this way of introducing additional gravity would work. So in any case, a long story explaining why NSF was finally interested in funding a facility that everybody could use. So they established a committee, and I was chosen as the chairman of that committee. The committee was to search for and solicit, I should say, to solicit proposals for the establishment of a geotechnical centrifuge facility. The committee, the three members that I remember, in addition to myself, HarrySeed, BobWhitman, NevilleCook, and there were one or two other members whom I just don't remember.
BruceBolt? BruceBolt?
BruceBolt.
Yes.
Yes. And in any case, of course, NSF provided all of the boilerplate in terms of producing the paperwork to send out, and there were probably about 8 to 10 proposals that came in. So then this committee reviewed those proposals and settled on 5 of them that looked most promising to make field trips. And we proceeded to as a committee, go to the sites that had made these proposals, and we visited along with Charles Babendreyer from the National Science Foundation. The facilities were proposed first, just random order here. UC Davis proposed to use an existing centrifuge at Moffett Field, South Bay, San Francisco. They would remodel that facility and move it to Davis. The University of Colorado proposed a centrifuge, a totally new facility to be built above ground on the campus at Boulder. Colorado School of Mines proposed a facility that they would, in which they would enlarge an existing cavity in their experimental mine in the Rocky Mountains, and then build the centrifuge in that cavity. There were 2 additional proposals, and I won't spend time describing because they fell out of the range of the probabilities. The Colorado University proposal included the expectation of hiring a young professor who would be graduating from Caltech with, what's his name?
From Caltech?
Yeah. Oh.
Who eventually went to Colorado, you mean?
No.
Oh, okay.
No, who was the advisor for this student.
Oh, I see.
His name will come up. RonScott.
RonScott, yes.
RonScott, yes. This was RonScott's student. Well, of course, I don't know, something, maybe Davis got wind of that, and so they proposed that they would send one of their young PhD students to Cambridge University in UK. Cambridge was probably one of, if not the leading proponent of geotechnical centrifuge testing. So in any case, those two were adding a proposed director for the centrifuge facility. Well, okay, so after deliberation, our committee selected University of Colorado. That we felt that they had the best plan, that they were going to have a moderately large centrifuge, not as big as the Davis, but quite big. And that from our viewpoint, that was the preferred site. Well, it turns out that there were higher levels of authority operating here than we knew about. I have to describe a little bit the existing centrifuge at Moffett Field had been built to train astronauts, and it had a long arm, and but its capacity at that time was probably maybe 15 Gs, and the reason was you're not going to subject humans to more than that on a sustained basis so in any case that centrifuge would have to be significantly modified. Well, the higher levels of authority wanted to be sure that that centrifuge got utilized. It had been built by federal money and was no longer needed. We knew what G's were doing to humans, and so it wasn't necessary anymore. So I believe because of political string pulling, NSF, who had the final choice, there's no question, selected University of California, Davis as the site for the National Geotechnical Centrifuge Facility. So they proceeded to modify the Moffett Field astronaut centrifuge. That included building a much stronger arm. You know, the centrifuge travels in a horizontal plane from the center, and the outer end of the arm will contain the model and be spun up to a certain level of G's. For practical reasons, you have to extend the arm in the other direction with a counterweight, or it will tear the thing apart. The astronaut centrifuge did not have a counterweight, didn't need it because it was a small enough operation. So in any case, the Moffett Field machine was modified at a steel fabricating facility in Oakland, California. and was moved along with the motor and the gear system to Davis. Initially, the facility was left in the open, no roof over it or anything. I digress a moment. The Colorado School of Mines facility was very attractive because they could use this facility, this already existing cavern, mold it to the right size, and then evacuate it. And it's important to evacuate so that you cut down the friction, and you don't want to create all that heat and so forth. So there was the advantage there of in a mine. But Davis chose first to leave it wide open and let it be cooled naturally in that way. So the system was installed, very large motors to a gearbox, and the centrifuge arm placed on it. First time they turned it on, somebody, and I can't tell exactly where the responsibility lies, forgot to check the lubrication and the gears, and they burned up the gearbox before it ever spun up to full speed.
Oh.
Well, that of course set the timetable for NSF way back, and was going to cost substantially more to replace the gearbox. The question then was,